Take a look at that circle worksheet. That's the one we're going to do first. Let's review really quickly some of the rules about circles. Let's make that an 8. Let's change that. Okay. This is an equation of a circle. Where is the center of this circle? Remember, the circle is h comma k, so 3, -8. And remember that the numbers inside the equation are the opposites of the h and k values that represent the center. So we have x minus 3, which translates into x equals 3, and we have y plus 8, which translates into k equals -8. So the center is opposite the numbers in the equation. Okay? And then what about the radius? Not half. Square root of 49. Right. So the square root of 49 is 7. This is called vertex form of a circle. Vertex form is really nice for being able to graph a circle. You could also have it in polynomial form, which is called standard form. Here's an example of a standard form equation. Well, let's do it this way. Okay, hold on, this will take me a second. Oops, minus 23. So that is standard form, which can technically equal 0. And we've dealt with standard form a lot in parabolas, in quadratics, like x squared plus 2x plus 6 equals 0. That's standard form, and it's really nice to find the roots in standard form. The standard form of a circle is pretty useless. We run into it quite a bit, but we don't use it for much of anything. What we want it to look like is x plus or minus something to the second plus y plus or minus something to the second equals our r squared value. So today, most of the worksheet is going to be similar to the one you did last time. And there are 4 problems where you have to convert from standard form into vertex form. And it's really easy to do. It's something we've done before. Okay? So what I'm going to do first is group the x's and the y's together. And I'm going to move that 23 to the other side. So x squared minus 6x, y squared plus 4y equals 23. So looking at this, I want to translate this x squared quadratic into a factor times itself. You ever seen this before? First of all, does this factor? It factors into x times x minus 6. Are those two factors the same? No, not at all. So x times x minus 6, those are not the same factors, so that is not correct. Well, is there a way to turn a quadratic into a perfect square? I was hoping you'd catch on by now. Something we did weeks and weeks ago. It has something to do with squaring it. Do you remember what it was called? Remember when we had a quadratic that was not a perfect square, and we move the constant to the other side, and we create a perfect square? Yeah, it's called complete the square. So I look at this negative 6x, and I cut it in half, and my perfect square is x minus 3. Well, does x squared minus 6x factor into x minus 3 squared? No. We're missing the constant. What is the constant that completes the square? 9. How'd you get that? Times negative 3 by itself, and we get plus 9. Am I allowed to do that? Yes, as long as I add it to the other side. So, vertex form of a circle requires that we have a perfect square factor. We don't have a perfect square factor, so we just add a little bit extra to make it a perfect square, and then as long as you add the same to the other side, the equal sign is still valid. If it's a balanced beam and you add to one side and then you add to the other side, we're still balanced, and that's all an equal sign cares about. It doesn't care how much one side weighs, as long as the other side weighs the same. So, what is the perfect square factor for the y values? Plus 2. Well, if 2 is my factor, what is the perfect square I need to add? 4. So I add 4 here, and we add 4 here. 23 and 9 and 4, if I did it right in my head, should be 36. And now I have vertex form, and I can find the center and the radius. Does that make sense? Let's try another one. Hold on. I don't know what number I'm going to put there. Calculator. Ooh, that's a really bad idea. Okay, hang on a second. Okay, hopefully this works. All right. First of all, how do I know that this is a circle and not a parabola, for instance? I have a y squared. If you have a y and an x squared, it's a parabola of some sort. Could be up or down. Okay? Well, what if it's a y squared and an x squared? How do I tell the difference between a circle, an ellipse, and a hyperbola? Well, for a hyperbola, the x squared and the y squared have different signs when they're on the same side of the equation. So if I move that y squared to the left side, we have a positive x squared and a positive y squared, which means it's not a hyperbola. If you have x squared minus y squared or y squared minus x squared, it's a hyperbola. So we can eliminate that. How do we tell the difference between a circle and an ellipse? Right. So in an ellipse, you have a major axis, which is the long axis, and a minor axis. And it could be the other way around. It could be this way. And those axes are determined by the coefficient in front of the x squared term and the y squared term. So, for instance, if I had like, it's not quite this simple, but 9x squared and 4y squared, then we know that one of the axes is longer than the other axis. Okay, and again, it's more complicated than that. But what if those two axes are the same length? Well, if your minor axis matches your major axis, then you have a circle. And those two foci, the two pins that we use, if they come together into one point, it's a circle. So if you look at the coefficients, the one here and the one there, they're the same, which means it's a circle. If they were both 4s or 8s or 24s, it would still be a circle. It makes it a little bit harder to complete the square, but you can still do it. Okay, so we know it's a circle. What should we do in order to write this in vertex form?